So here we are, week 1, chapter 1, elementary surveying. So this is an introduction to geomatics, introduction to surveying. We're going to talk about material right out of the book. You should have read the chapter by now. This is the summary in lecture over the book. Section 1.1 goes over the definition of surveying, and that's a good general explanation. You'll find very similar language in the statutes, the codes, the laws that define surveying and what surveyors can and must do. What I would stress to you is that surveying is the science of measurements that accounts for error. And that was taught to me by my first surveying class many years ago at Southern College of Technology. That's exactly what he said. If you don't remember anything else from this course, remember that surveying is the science of measurements that takes into account that there is error. Now let's expound a little bit. It means there is no perfect measurement. Our textbook math problems have always been, turns an angle of 33 degrees. It goes this far, the sine and the cosine. You compute, well, it's not 30 degrees exactly, and even if you use a $30,000 instrument, you're still not going to get exactly 30 degrees. You're going to get really, really, really close, but there is error in every angular and distance measurement made. And that's how surveyors have surveyed for millennia, not just centuries or decades, but millennia. We measure angles, we measure distance. The tools have evolved, but that's how it's been done. Now, in the last decade or so, GPS is used more. GPS, listen to this, does not measure. GPS surveying is not measuring, it is positioning. And we'll talk about that, but that's a little bit of a mind blow maybe for some of you that's got some experiences that we don't really measure with GPS, we position. And it's two totally different approaches, equipment sets, and math to get very similar, if not hopefully identical, results. Section 1.2 says it's geomatics and it's virtually interchangeable. Well, geomatics is more the broader discussion of surveying. That's basically, geomatics is basically synonymous with geospatial science. So that could include some GIS, some laser scanning, some LiDAR collection, some remote sensing, some bathymetry. It's basically everything that deals with measuring and science and earth and measurements and maps would be geomatics. Surveying is sort of a subset still of geomatics in that it's actually going out and doing measurements or observations or positioning to create a professional work product. And one thing that separates what surveyors do from what GIS folks do or Google Earth does is that surveyors' works are authoritative. In other words, they're not implied, they don't have disclaimers, they're not, use at your own risk, plus or minus this. When a surveyor does something under a proper license that's issued by the state under the code section, then the public or the user of that map, work, report, etc. has a reasonable expectation to rely on it for a lot of things, and we'll talk about some of that. 1.3 is the history of surveying, and that's surveying goes back, the textbook says it goes back to like the 12th or the 15th century BC. It actually goes back further than that. In the Old Testament of the Christian Bible, you'll find where Moses gave instructions on how to divide the Holy Land, basically survey instructions and legal descriptions, dividing the Holy Land, the Promised Land, into 12 different divisions for the 12 tribes of Israel. And but as far as a more exact recorded science, that's in Deuteronomy 19. It also says, thou shalt not remove thy neighbor's landmarks, which they of old time have set. So our culture, regardless of your religion or ethnicity, our culture on the earth goes back many centuries and millennia, and has recognized boundaries and their importance. Now, the book speaks about the Egyptian rope stretchers. This is a neat painting of Egyptian rope stretchers. They realized that the Nile River flooded every year and wiped out whatever benchmarks or markings or whatever they had there on the ground. All signs of it was washed out by the flooding. And then they came back the next year to cultivate it. So to keep everybody cultivating their own land and not somebody else's, they used ropes to measure. They had landmarks set up outside the floodplain for direction, and they used the ropes to set forth and lay out the measurements, the distances, so that they could identify where everybody's fields were for cultivation of rice and cane and corn and these things. So I've always thought that was pretty neat. As we get into just a few centuries ago, people like Galileo and a few others, they created the diopter and the gromma to have man-made tools to do a better, more repeatable job of measuring angles and bearings and things. And they still were using ropes or chains to measure distances because that's just all there was. Still on the topic of the history of surveying in our country, this is real important for all of you to know and remember. Mount Rushmore is a carving of 3 land surveyors and a cavalry officer. So Washington's first job at the age of 17 was he worked with the county surveyor's office in Culpeper County, Virginia, which was a colony of England at the time. And then his surveying and mapping and navigation knowledge helped his military career to limits that you can read about in all of our history books. Thomas Jefferson was also a surveyor. He and his brother had a small surveying company at one point in time in their lives. He also dabbled in surveying. And Washington didn't just do it briefly. Washington, just months before he died, surveyed his last tract of land after he had retired as President of the United States. I believe it was a 69-acre tract of land somewhere there near Mount Vernon, Virginia, that Washington went and surveyed just months before he passed away. Jefferson used his knowledge of surveying and mapping to illuminate the exploration of the West. The Lewis and Clark expedition was Jefferson's brainchild, and he got with Meriwether Lewis and made sure that they were on the same page as far as how they were mapping things. Little known, Abe Lincoln surveyed briefly. He decided that he had a hard time making a living at it because he was trying to do too good and too thorough of a job, and he got really interested in the legal side. So he wound up leaving surveying and went into law, became a lawyer, and from there he became a politician, and then of course president. And Teddy Roosevelt was one of the first great conservationists, and was not a surveyor, but I understand he did some really good feats as a cavalry officer. Section 1.4 explains to the reader that there's a difference between plane surveying and geodetic surveying. Now, we don't mean plane as in plain old, we mean plane as in the geometric term plane, P-L-A-N-E. Most surveys that we'll work on in our careers are of a small enough area that we can treat them as planes, as if the world is flat at that point. And I think the largest project survey development, I think I've got a development that's around 5,500 acres, and the largest boundary survey we've done, I think, was 6,300 acres over northeast Alabama a few years ago. And those are pushing the limits to be plane surveys, but laws for boundary surveys are plane surveying laws, even though geodetic science will factor in, especially with the use of GPS. But geodetic surveying is where we're taking into account curvature and refraction of the earth all the time, and that's because they're usually over very large areas, at least counties, maybe states, maybe entire regions, and we're dealing with precise measurements where those curvature and refraction corrections that may be within the level of tolerance for a boundary survey, they become very important for geodetic measurements. And so Here is a picture of a total station. A total station is an instrument that measures angles and distances. Most all of them that I know of that are manufactured now are all fully electronic. They don't require any interpolation, reading of any dials or anything like that, and they will transmit. Used to be through cords, now they're basically all Bluetooth to a data collector, controller, electronic field book, whatever term you might like. And along those same lines, here is a GPS receiver. This is a Carlson BRX7 that someone is collecting a position on using their tablet. So that's the sort of things that we do. Section 1.6 goes into the different types of surveys. We'll cover a lot of those. Please read that. If you have any questions, let me know. Section 1.7 touches, albeit briefly, on surveying safety. It's very important that we have safety mechanisms in place. I've been involved with a lot of surveying injuries. Some required stitches, some required casts, some required surgeries. They're almost, but not completely, all avoidable. And sometimes, especially when working around traffic, we will have a few fatalities each year of surveyors that are working along traffic. And it's usually that a driver goes past a barrier or swerves off the road or something. You have to be mindful of your surroundings and have situational awareness when you're surveying. Wear high visibility vests. And if you're going to be around a road, it's good to not be doing solo surveys around a busy road so that one person can help watch for you. And that's an absolute requirement with railroad surveys, actually, even though you can hear a train coming a lot easier than you can a car. I skipped over 1.5, the importance of surveying. Realize this. This is why there's such a growing demand for land surveyors in this country. Most projects, most big real estate transactions cannot happen without a surveyor. Surveyors are not thought of that much in society. A lot of people go through K through 12 and even through college without ever knowing what surveyors are or what we do. Yet no construction project that you'll be involved with beyond a simple house, but even then in most counties you're going to have surveys to start a simple residential project, a road project, a sewer project, a big construction project for a commercial building or even a stadium or whatever, a railroad. All is going to require precise, reliable survey data as the cornerstone that project is built on. And even after it's built, in order to get title insurance and to get commercial lending and funding from banks and investors, properties are going to have to usually have ALTA NSPS land title surveys. Even if they don't require ALTA surveys, at some point they're going to have a survey to delineate and demarcate and define what's being sold. It's not just, half an acre or so with my house on it is not a valid legal description, and nobody in their right mind would buy that, but more so no bank or title insurance company is going to touch anything that vague this day and time. Even the mass grading subdivision projects that you see where they take 20 acres of land, regrade it, engineer it, design it. I'm not taking away from the engineering and the design side. That's very intricate, very mind-blowing as to what technology will allow engineers to do, and even earth moving equipment with GPS operated machine control. It's mind-boggling what all that can take place there. But at the end of the day, when you have a closing and you sell one of those houses, it's got a final plat on record somewhere that bears the seal of a professional surveyor that was done to state standards, and the surveyor is going to certify to whoever buys that property that it was done right. And so that's who everybody down the line is banking on. And sometimes surveyors don't play by the rules, or they don't do a good job, or people get by without surveys and transact property either purposely or maliciously on false pretenses, and you wind up being sworn in by Judge Bagley over in Forsyth County because somebody's suing your pants off. We don't want to be this guy getting sworn in as a witness right here. This is actually somebody getting sworn in as a new attorney, but it's a great photograph that was publicly available, and I know the judge. And but you don't want to be sworn in as a defendant in these situations. Section 1.8, GIS. Some of you are familiar with GIS. Some of you plan to take GIS courses. Some of you may have. GIS is a wonderful tool. I've had a GIS course. I'm not very fluent in it, but I have made maps and derived and manipulated data using ArcGIS, and it is amazing what it does. But it is not surveying. It is not surveying software. It is a wonderful tool. The last two letters tell you exactly what it is. It is an information system. The metadata that can be tracked through a GIS system is, it's hard to imagine, basically. But that's what it is. It's an information system. Now, in order to do it, the G stands for geographic, so it's all map related. It all relates back to a map. But it's not survey grade. It's not survey measurements. It's a compilation of geographic data and other metadata. In the land surveying world, GIS has a different meaning for that acronym. GIS stands for Get It Surveyed. A lot of lawsuits, a lot of broken hearts, a lot of financial problems have been derived because people have purchased or developed property without getting it surveyed, assuming that the GIS map, QPublic, ArcView, whatever, that it correctly showed them where it was, and that the coordinates that they pulled from GIS were downloaded into a smartphone or a handheld GPS receiver that they bought at the camping store, and that's what they went by. It could be off 20 or 30 feet easily. 50 to 100 feet is not uncommon. I was involved in a lawsuit between two counties where the property line and the county line was off by 11,000 feet. The survey data never moved. The survey data and the acts of the legislature, which define the county boundaries, never changed since 1832. Somebody got a map wrong, and then that mistake was repeated and repeated and repeated for decades until some people started getting tax bills and voter registration notices from two different counties. Now, they didn't mind the idea of voting in two different counties too much, but paying taxes in both counties at full rate kind of got their attention. So, yeah, GIS is great, but get it surveyed. There are federal agencies. This is 1.9 that provide support and data for surveying. They do not regulate or license surveying. The National Geodetic Survey provides a lot of data, a lot of information. They're very hands-on. The USGS, the U.S. Geological Survey, provides a lot of mapping resources. It's kind of like NGS is surveying, USGS is mapping. BLM is the Bureau of Land Management. It's paired with GLO, the Government Land Office. This deals with government lands and public lands, even those that have been conveyed by the government for over 200 years, going back to like the 1785 land ordinance. The Bureau of Land Management has records of this and how most of the United States was divided into public lands. Here in Georgia, we were one of the original 13 colonies, and so we do not have the U.S. rectangular land division system, and so there are no BLM records, no Bureau of Land Management records for the state of Georgia, and the U.S. Army Corps of Engineers also does a lot of surveys, benchmarks, engineering works, and things. The surveying profession is one that, as I spoke to, it is shrinking, and so demand is growing, and thankfully so are wages. After doing this for 38 years, I'm very glad to see the earnings potential for surveyors finally coming around to where it should be. The book speaks about right of entry laws. That varies from state to state. That basically means do you have the right as a surveyor to go into somebody else's property to measure a landmark or a benchmark or some reference station. About half the states have right of entry law. If you're either a licensed surveyor or working under the direct supervision of one, you're okay. You cannot be arrested for trespass. Georgia is not one of those states. We do not have right of entry. But as I've talked to 2 or 3 Superior Court judges who say they would not have a surveyor arrested or charged for trespassing as long as they were minding their business and not damaging someone else's property, because we have other law that says you have to go do this. So it's kind of implied in Georgia, but we still don't have the right to trample on people's rights. 1.11, professional surveying organizations. We are professional size. We have American Land Title Association, which is not a surveying society, but is a national organization, and they do work with NSPS, the National Society of Professional Surveyors, and they do create what's known as the ALTA survey standards, which you would learn about in 4475. Next thing that they talk about is let's see, we're still on professional organizations. Here are some in Georgia. The Surveying and Mapping Society of Georgia, known as SAMSOG, that's the acronym, and we have the Professional Engineers and Land Surveyors Board. Now that was changed by law in 2022 or 2021, the year that I cycled off after 18 years. Prior to that, it was the Georgia Board of Registration for Professional Engineers and Land Surveyors. Now it's just the Professional Engineers and Land Surveyors Board. And there'll be more about that in other classes. One thing here in 1.12, Internet capabilities and technology. When I began my career in the 1980s, everything was paper. Obviously, there was no internet. There was before fax machines. We had to go to the courthouse and make copies of deeds and plats, and sometimes if they were too big or if the machine was down, we had to trace them or make hand reproductions, basically. Tax maps and flood maps were paper. They were not things that could be viewed online. Instruments were basically direct read. We had verniers that we looked through and lined up lines in order to get angles on our GTS 10D Guppy and our GTS 2B total stations. And they manually read out distances. Thankfully, I've only about twice had to use an actual calibrated steel tape on the job as a surveyor, and that was when the battery died of our EDM, and another time when the EDM just puked and it had to go to the shop. But thankfully, we were at a good stopping point both times. And so things have changed a lot. Technology is really awesome. We have geo-referenced aerial images that are available from paid services. Not just, what you see on Google Earth is wonderful, but it might be off a few feet, and it's hard to get it geo-referenced. We use some subscription services that will put them to 6 inches or sometimes less of pixel resolution and on state plane coordinates, like a GIS system would. So 1.13 is future challenges, the growing workforce, and the shrinking amount of people that want to do it. There will be more and more challenges, I think, as you see developed areas that people realize are moving or settling. Earthquakes change the relationship of benchmarks and property corners to each other. Places like New Orleans and a lot of areas around the coast, and even some places in the Midwest, as improvements are built and developed on top of property, they begin to actually settle into the ground. And it's almost imperceptible. It's almost like a little miniature tectonic plate. And there's more and more surveying and monitoring. Subsidence is when it moves up and down. Deformation is when it moves around left and right. There's going to be more for that. We've been working for decades now on North American data of 1983 as far as our state plane coordinates go. That's about to change with brand new projections, the 2022, which supposedly will go into effect this year. We will see state plane coordinates are going to be more of a time position oriented formula, very different than all of our other projections that came about. And there's always new technology. I'll leave you with this, and land survey class that I took, which was the predecessor to professional practices back a long time ago, the hallowed Professor Al Trammell said, in speaking of having respect to measurements and monuments set by previous surveyors, he said, one day you may see the ability to walk into the woods without an instrument and develop coordinates that are precise to a hundredth of a foot or so. And just because you can measure more precisely and better then than you can now doesn't mean that what you're doing now is worthless. It will still have the same legal weight if it's an original monument, even if the measurements don't check out as well in the future. And we all kind of snickered, and he said, well, there is technology coming called global positioning systems. And you will learn the acronym GPS and learn to appreciate it in your careers. And that was the first time I believe I remember ever hearing about it. And that was, I believe, less than 10 years from when the Department of Defense launched the first land navigation satellites, at least that had any kind of civilian availability. So the technology that I've seen in my career is remarkable. If you look at someone whose career ended when mine began, they were just beginning to see electronic distance meters coming out, but everybody was still using chains and transits and theodolites and manually drafting and manually drawing plats like they had for hundreds of years. In 1975, they were using the same technology and the same type of equipment as they were when they laid out Washington, D.C. Like 200 years earlier. So little had changed. A little bit had changed probably in the few hundred years before 1775, but it was we've seen incredible technology advances in my career, and there's more to come. I can only imagine what those of you will see in the changes of technology in your career. Looking forward to a great semester. This concludes Chapter 1, Module 1. I try to keep my lectures in this class to less than 30 minutes. Hopefully that makes it easier to manage your time and keep attention spans. We will see you next week, next module. Thank you.